Sections the ellipse. Definition of an ellipse is the set of all points x, y in the plane, the sum of whose distance from two distinct points, foci, is constant. So here's focus 1, focus 2, or foci 1, foci 2. And you go to any point on the ellipse, you add those two segments together. It will be the same as these two green added together, these two blue. Now, if we put this in our xy coordinate plane, let's say we connect these foci, and they're all going to be on our x-axis. This would be at negative c comma 0, c 0. So we're going to let the distance from the center to the foci be a distance of c. And this point P is going to be xy. Okay? Now, if we wanted to find some more point values here, for example, we put point P up on the y-axis like we did right here. Okay? Here's your C. Then this distance up to here from 0 to B, we're going to call that our minor axis. Should be from negative B up to B. This is our shortest distance. Your major axis, negative A to A, that's the longest distance. And you have a right triangle here where the square root of b squared plus c squared will equal a, which is the length from the center out to this point right here. Now, as it stands, these are the general forms for your ellipse when you're centered at the origin. If you look at these two here, you'll notice a distinct difference. One case, a squared is below the x squared, b squared is below the y. Over here, a squared is underneath the y, b squared is underneath the x. A squared, based on the restrictions, is a is always greater than or equal to b, greater than 0. So a and b are going to always be positive, and a is predominantly going to be bigger than b. So the denominator with the biggest value is your a squared, and since it's under the x, it's going to be stretched more along the x-axis, where over here a squared is underneath the y squared. Now it's more stretched in a vertical. So over here we call this more of a horizontal orientation. This is going to be more of a vertical orientation. Now if we move our center away from the origin, then we have to insert our x minus h and y minus k binomials, but the same rule follows for the bigger number underneath whatever variable, and that's where we do most of our stretching of our ellipse. Again, to find the foci, think of this as the Pythagorean theorem with a minus sign. Your vertices, now I don't believe in this part right here because vertices are defined as a point where your direction changes. Yes, that changes at negative a comma 0 and a 0, but it also changes right here and here at the bottom at 0b and 0 negative b. So this author has chosen not to talk about these two vertices, only talks about the vertices at the end of what we call the major axis. And the length of that major axis is 2a. Well, the minor axis is from 0 negative b to b. That's a distance of 2b. So some teachers or authors of books will call these the major vertices and these the minor vertices. Major because they're at the endpoints of the major axis, minor vertices because they're the endpoints of the minor axis. Some teachers and instructors also call these just vertices and co-vertices. Same concept, just something to distinguish between the two. We have to find those points in order to help us graph. Now, if your a and b are equal to each other, then you have a circle, not ellipse, and your radius would be the value of a. Okay, now another distinct fact I want to point out here is that if you were to put this triangle, flip it over to here, and draw another triangle right here, your f1 to some point to f2 would be a plus a. So this constant sum that's in the definition, make a note. It's the same distance as your major axis, 2a. So from negative a to a, that distance is the same as these two segments added together. All right, let's look at an example. So find the center, vertices, and foci of each ellipse and sketch it. Well, right away, I see nothing being added or subtracted to my x and y, so that tells me my center's at the origin 0, 0. Next thing I want to do, after I plot my origin, is find the a values and b values. The biggest number is 36, so that's my a squared equals 36. A is equal to plus or minus 6, and I like to draw an arrow left and right because it was underneath the x, so that's my x-axis going left and right, so that's where I need to count. 6 to the left and 6 to the right. And so there's my vertices. You can write these as two separate points, 6, 0 and negative 6, 0, or use the plus or minus symbol. That either one's fine by me. Now, we also have to find, if we have to plot this, your co-vertices or minor vertices. That's your b squared equaling 9. Solve for b. That's going to be plus or minus 3. And because I'm underneath the y, it counts up and down. Please do this because it's going to help with the next conic section as well. So up and down 3, and then I can draw in my ellipse. My foci is the Pythagorean theorem with the minus sign. A squared minus b squared equals c squared. To solve for c, you take the square root of both sides, plug in your a squared and b squared is 36 minus 9, which is 27. So the square root of 27 simplifies to 3 radical 3. Might want to find the decimal for when we plot those points, but again, the foci are always on the major axis. So whatever changes you make to the major vertices or vertices, I change the x by going plus or minus 6. You change the x coordinate again, plus or minus 3 radical 3, 0. So again, changing that to a decimal value, it's slightly bigger than 5. So there's my focus points or foci points. Second example. Here, we're going to start with an equation that's in the generalized form, where it's set equal to 0. We still got to find the center, vertices, and foci, so we still got to get this type of equation set up. So what we're going to have to do is we're going to have to complete the square here. So I'm going to group together my x terms, x squared plus 2x plus a blank constant for my x, 3y squared minus 12y plus blank, but you want the y squared by itself, so I factored out the 3 right away, equals, I'm going to subtract over the 10, put in a plus blank for the x's, and I'm going to put in the plus 3 blank here because we got to multiply the 3 to whatever value we put here. So to fill our blanks, half of a positive 2 is positive 1 squared is 1. Half of negative 4 is negative 2 squared is 4. So here on the left, we'll have x plus 1, that binomial squared, plus 3 times y minus 2, that binomial squared. And combine everything over here, negative 10 plus 1 plus 12 is 3. And if you remember, back in our definition, we said these had to be set equal to 1. So we got to divide this 3 into everything. So we'll put 3 in the denominator underneath the x plus 1 squared, divide 3 into this binomial, the y minus 2 binomial squared, and 3 here. So that gives us a 1. These cancel out to a 1. I like to leave the 1. It's optional. You don't have to. The reason I like to put it there is because now when I come to find my vertices or my co-vertices or minor vertices, I have that 1. I know I need to do something with it. So our center, negative 1, positive 2. Plot it. Find a, b, and c. A squared is equal to 3, so the square root of 3 is like, what, 1.7-ish? So left and right, positive 3, square minus square root of 3. So vertices, negative 1 plus or minus square root of 3, 2. Co-vertices, or minor vertices, that's from the 1, b squared equals 1, so up and down 1. So I can draw my ellipse. My foci, a squared minus b squared equals c squared. Take the square root of 3 minus 1, which is going to be 2. So again, just like I did with my major vertices, negative 1 plus or minus the square root of 2, 2. And then plot those points. All right, off to example number 3. Now, they give us a graph of an ellipse, and they want us to find the equation and the foci. So what I would like to do here is I would like to take my ellipse and cut it horizontally and vertically in half. So now I can see where is the center of my ellipse. It's not on the origin, so I know I have to use my form with x minus h squared and the y minus k binomial squared. So here I can identify my center as at 2, 1. So I can put that in for h and k. And then I'm going to find my value of a, centered to the farthest point, 3. Centered to the shortest distance, 2. So a is equal to 3, b is equal to 2. Going out to my vertices and co-vertices, or major vertices, minor vertices. Plug those in for a. 3 is squared is 9. 2 squared is 4. There you have the equation of our ellipse. Now to find your foci, 9 minus 4 is going to be 5. We need to take the square root of 5. And again, that's horizontal, so we have to change your x-coordinate of 2. 2 plus or minus the square root of 5, comma 1. Example 4, find the equation of a conic that satisfies the given conditions, the ellipse with vertices 0, comma, plus or minus 8, and foci 0, comma, plus or minus 4. So I'm going to plot those points. Halfway in between my vertices has to be my center. So this has a center at the origin. So a is 8. Foci 0, 4 to 0, negative 4. C is going to be 4. My general form of the equation now has the a squared underneath the y squared, because notice my vertices are going up and down for my major vertices. So we have to put the bigger value underneath the y squared, which happens to be 8 squared. But to find b squared, we have to use that Pythagorean theorem with the minus sign. So we'll have 64 minus 16 is 48. Don't take the square root of 48, just put it in for b squared. And there's your equation of our conic section. Okay, example 5. Find an equation of a conic section that satisfies the given conditions. The ellipse with a major axis of 6 and foci at 0, 0, and 4, 0. So I'm just going to draw an xy coordinate plane so I can get this to fit in there. There's 0, 0, and 4, 0. Now, the major axis of 6 tells me that 2a is equal to 6, and that way a is equal to 3, so my center being halfway between my foci, which will be at 2, 0, I'll count 3 squares to the right and 3 squares to the left for my vertices. So a is equal to 3 and c is equal to 2. So I can see we have more of a horizontal ellipse. We are not centered at the origin, so we're going to need our x minus h and our y minus k format. Put in the 2 for the h, the 0 for the k, so we can just call that y squared. A was 3, we can put 3 squared here, or 9. And then we just have to go solve for b squared. So we're going to have to go 9 minus 4 is 5. That's your b squared, and we'll just put 5 underneath our y squared, and you have your equation. Okay, example 6. Find the equation for a conic section that satisfies the conditions ellipse and with foci at plus or minus 4, 0, and passes through the point negative 4, comma 1.8. That's kind of interesting here. So based off of my foci, just like we had up previously, we're going to be at the center here, because halfway between negative 4 and positive 4 would be 0, 0. So this is my standard form of my equation. And again, with the changing of the x-coordinate tells me that a squared has to be underneath the x squared, because that's going to be the major axis. So we'll make a graph, plot some points, negative 4, 0, 4, 0 for the foci. There, like I said, origin's at 0, 0, my c is 4, and my point P is at negative 4, 1.8, directly above that focal point. Whoa, I got to go find a squared and b squared. Oh, that's right. Remember I said that the distance of that constant sum is the same as the distance of the major axis to A. So let's add these distances together here. So P to F1 and P to F2 has to equal 2A. Well, P to F1 is 1.8. That's that y coordinate. P to F2, we have a right triangle here. So that's going to be 1.8 squared plus 1, 2, 3, 4, 5, 6, 7, 8. 8 squared. Crunch the numbers here. That becomes 8.2. Add this together, we get 10 equals 2a, and a is equal to 5. Now that I have my a is 5, I can plug that in for a squared, and then my c is 4, I can go find b squared. So 25 minus 4 squared for c squared, 16, is 9, so we'll replace b squared with 9, and there's our equation of the ellipse. Number 7, our last example, I believe, for our conditions here for an ellipse. Our center's at -1, 4, so that's your h and k. Vertex at -1, 0, foci at -1, 6. So we should probably plot some of these points. So I make my x and y axis. There's my -1, 4. My vertex, -1, 0. Foci, -1, 6. So foci distance is a c of 2. Vertex distance for A is going to be 4. Now, if you want to put in the foci down here and the vertex up here, you're more than welcome to, but it's not necessary. We did this just to find the value of A and 2, and you'll be solving for a lot of B squareds here. So let's put in our general form, x minus h, y minus k format. -1 goes in for h, 4 goes in for k, and 4 squared for a squared, so that'll be 16. And with the minus, the -1 changes that to a +1. So now let's go find b squared. So 16 minus 2 squared, which is 4. That's going to give me 12 for my b squared, and we'll plug that right there for our b squared. And there's my equation. Now, definition of what we call eccentricity is given by E sub cc. That's for the two c's right here. Is c over a. So if your ratio of c over a is really close to 0, then your foci are closer to the center of the ellipse and looks more like a circle. If my c over a is closer to the value of 1, then the foci are closer to the vertices and looks more elongated. We stretched it more. Okay? All right, next stop will be our hyperbolas.